A single Patriot missile interceptor costs about $4 million. They take months to build, and global production is currently limited to just a few hundred units a year. Compare that to the Shahed 136. These explosive kamikaze drones cost roughly $35,000 each. They are built using commercially available parts and roll off assembly lines by the hundreds. For Western forces, defending against these swarms is a war of attrition, where the defender loses money with every successful hit. Shooting down a $40,000 drone with a $4 million missile is a financial strategy that eventually runs out of both cash and interceptors. National security now relies on a different metric: the ability to mass-produce reliable, expendable aircraft at the absolute lowest cost. But looking at the global commercial market, there is a massive supply bottleneck. A single Chinese company currently controls 70 to 80% of the entire market. For Western militaries, this dominance presents a critical vulnerability. Drones process vast amounts of visual data and rely on constant communication. The risk of built-in hardware backdoors or the threat of a manufacturer remotely grounding entire fleets has led democratic nations to ban these systems from their defense networks. This mandate to de-red created demand for a trusted supply chain. In 1 year, Taiwan's drone exports to Poland and the Czech Republic surged 35 times over. Geopolitical anxiety has fragmented the global market, creating an urgent demand for a trusted supply chain that the dominant Chinese manufacturers can no longer legally satisfy in the West. Taiwan's historical advantage is a dense network of small and medium enterprises. This industrial muscle is heavily concentrated in a tight corridor around Dadu Mountain. These factories are built for agility. A company that spent decades manufacturing industrial ceiling fans is repurposing its assembly lines to produce military-grade drone motors. Manufacturers that normally build backup cameras and radar systems for the automotive industry are recalibrating their production to supply optical sensors and targeting lenses for unmanned aircraft. Because these suppliers are often located within a few miles of one another, engineers can prototype a new drone frame, drive down the street for a custom motor, and test the integrated system in a matter of days. The speed of this transition comes from the factories themselves, an existing world-class ecosystem simply applying its agility to a new set of hardware requirements. But stripping out Chinese parts introduces a difficult financial dilemma. A mass-produced Chinese image transmission chip costs about $300. A European equivalent can cost over $3,000. The only way to lower those prices is through volume. As the world's leading semiconductor foundry, Taiwan has the raw fabrication capacity to print these communications chips by the millions, bringing costs near consumer levels. Beyond the physical capacity, Taiwan operates primarily on an original equipment manufacturer, or OEM, model. They build hardware for other companies without using that intellectual property to launch competing brands. Taiwan also faces its own immediate geopolitical threat. This makes them highly motivated to build and secure an independent defense supply chain that is resistant to outside interference. They offer the democratic world an irreplaceable combination: the raw silicon output to drive down costs paired with absolute geopolitical alignment. Stamping metal frames and printing silicon is only half the equation. The industry faces a deficit known as the 3 chips, 2 softwares problem. While Taiwan can physically build flight control, communications, and GPS chips, they lack proprietary flight control software and a unified development platform to make them work together. Modern warfare relies on C5ISR, a framework for command, control, and intelligence. It is the software architecture that allows hundreds of drones to share target data, use AI for autonomous decisions, and fly as an intelligent swarm. Without bridging this software gap, Taiwanese factories are building beautifully engineered hardware that lacks the brain required for automated modern operations. To bridge the gap, Taiwan is looking to partner with nations like Ukraine, exchanging manufacturing scale for combat-proven algorithms developed directly on the front lines. By injecting foreign combat data and command software into Taiwan's production pipelines, the alliance can create intelligent swarms that operate in perfect synchronicity. This capability extends beyond the battlefield. Mastering the software to manage a military drone swarm provides the foundation for automated logistics networks during peacetime, fleets that can be repurposed for defense if needed. By fusing software intelligence with manufacturing scale, Taiwan positions the drone industry alongside semiconductors, creating a second strategic pillar that deepens its value to the global economy.